Good morning, students. Now we'll see some more problems in wave particle duality. I'll start with de Broglie wavelength problems in de Broglie matter waves. Now there is one question. The potential energy U of a moving particle varies with x as shown. Okay, right, up from x equal to 0 to x equal to 1, potential energy U is E. Okay, beyond 1, right, potential energy is becoming 0. The wavelength of the particle in the regions 0 less than or equal to x less than or equal to 1 means in this region and x greater than 1 are lambda 1 and lambda 2 respectively. That is, in this region it is lambda 1, right? Outside this one, beyond 1, it is lambda 2. Okay, if the total energy of the particle is Ne, total energy E, right, is N into E, the ratio lambda 1 by lambda 2 equal to how much? Okay, what is de Broglie wavelength? For general formula for de Broglie wavelength is, right, lambda equal to h by under root 2m into ek we know. Okay, de Broglie wavelength. So lambda 1, that is in this region we want to find out kinetic energy, right? Total energy of the particle is given as N into E. Okay, in the region, right, less than 1, potential energy itself is U, given as U. So kinetic energy Ek equal to total energy Ne minus what you call potential energy E. That is E into N minus 1 is the kinetic energy of the particle in the region 1. So lambda 1 equal to h by under root 2m into E into N minus 1. This is lambda 1 value. Okay, next one, lambda 2. In the second region, here potential energy is 0. Means total energy is entirely kinetic in nature. So we can take the kinetic energy in this region 2 as directly Ek equal to, right, Ne only. Therefore, lambda 2 equal to h by under root 2m. Ek is nothing but Ne, it is E. Okay, now look at this difference. Lambda 1 by lambda 2 is asking. Okay, I'll slightly modify this expression as h by under root 2me into root of n minus 1. Okay, I have taken out this n minus 1. I'm writing it separately, that's all. Okay, and what about this? I'll write this also, modify it like this. H by under root 2me into 1 by root n, I'll write. Simply rearranging the terms, that's all. Okay, now lambda 1 by lambda 2 means this by this. Okay, h by under root 2me, h by under root 2me gets cancelled. Root n minus 1 by root n minus 1, that is nothing but lambda 1 by lambda 2 equal to root of n by n minus 1. Okay, so what are the options given? Just go through the options given, right? N by n minus 1, root n by n minus 1, n square by n square minus 1, n square by n square minus 1. Okay, here it is, right? Root n of n by n minus 1. Root n of n by n minus 1 is the correct option. Okay, right? Next we'll go to the next problem. Okay. A particle of mass capital M at rest decays into two particles of masses m1 and m2 having non-zero velocities. The ratio of the de Broglie wavelengths lambda 1 by lambda 2 means a particle at rest is decaying into two particles, okay, m1 and m2, and those two particles are moving with non-zero velocities, means both are moving only. Okay, what is the ratio of the de Broglie wavelength? Okay, now why I have chosen this problem is, this problem has appeared till now in almost all the exams from 10 plus to level in what you call normals, local, state engineering medical entrances to IIT JEE to NEET to IIT JAM to ultimately in what you call GATE also this question has appeared. Only with slight modifications, that's all. Okay, a particle of mass 3m right? So decays into two particles with m and 2m masses. Okay, right? What is the ratio of their de Broglie wavelengths, like that? Okay, the concept here is a particle of mass m, right, at rest. This is important one. At rest decays into two particles. This here he has not mentioned what are the masses also. Sometimes they will give you masses in the ratio 1:2, masses in the same ratio, etc., etc., whatever it is, variations. Okay, two masses m1 and m2. Okay, velocities are not given. With non-zero velocities they said v1, v2. Okay, the ratio of the de Broglie wavelengths lambda 1 by lambda 2 of these two masses is m1 by m2, m2 by m1, 1, right, root of m2 by m1. Here the important thing we have to consider is what? The concept of conservation of linear momentum. Okay, initially the particle is at rest. So what is its linear momentum? 0. The total initial linear momentum must be equal to total final linear momentum. Momentum must be conserved. Okay, initially momentum is 0 means final momentum also should be 0. How is that possible? Only when momentum is a vector quantity, only when the two particles are moving in opposite directions, right, and their momenta, if they are equal, if one is taken as p, other one will be taken as minus p, such that the total final momentum also becomes 0. Okay, because one particle's momentum, if it is p, other particle is exactly moving in the opposite direction with same momentum, so its momentum will be minus p, such that then only the final momentum will be 0. Okay, the concept here is conservation of linear momentum. As the initial momentum is 0, final momentum also should be 0. Okay, initial momentum is 0 because the particle is at rest. Final momentum should be 0 when two particles are moving. How is that possible? They should be exactly moving with equal momentum, equal in magnitude, opposite in directions. Then only final momentum also can be 0. Okay, right? That's what the principle we apply in when I fire a bullet from a gun. Okay, you must have seen somebody firing rifles. If you join a what you call NCCs, like that, they'll fire the gun keeping the nozzle here. Okay, the handle here, they'll fire the gun. Initially the gun is at rest. When a bullet comes out with some velocity, for momentum to be conserved, right, the gun recoils backwards with equal and opposite momentum, so that final momentum also becomes 0. Okay, it's nothing but consequence of what you call action reaction forces, Newton's third law. Okay, now, so what should happen? This one's momentum and this one's momentum should be same. What is de Broglie wavelength? Lambda equal to h by p. Okay, so when momenta are equal, de Broglie wavelengths also will be equal. So what is the ratio? Lambda 1 by lambda 2 or lambda 2 by lambda 1, whatever it is, the ratio will be equal. Okay, simply because they should have equal magnitudes in momenta. Okay, this is why I have chosen this simple question, because it has appeared in almost all the exams I have seen. Okay, right? So we'll go to the third problem. Okay, now look at this one. Again, two photons having equal wavelengths have equal momenta. Okay, right? Two photons having equal two photons are having equal wavelengths, means lambda here, lambda here. Okay, have equal momenta, because momentum p equal to h by lambda. When they have same wavelength, their momenta are the equal. Right? Here one important thing is what? Momentum is a vector quantity. Two vectors must be equal, means they should be equal not only in magnitude but also in direction. Okay, if wavelengths are equal, magnitudes of their momenta will remain same, no doubt, but we don't know that whether they are moving in the same direction or not. If they are moving in different directions, their directions are different, vectors will not be equal. So we cannot say when what you call two wavelengths, right, two photons having equal wavelengths, right, they have equal momenta, we cannot say with guarantee. Okay, equal energies have equal momenta. Similarly, energy is a scalar quantity. If energy is equal, okay, photons energy E equal to h nu. Okay, right, nu equal to c by lambda, that is nothing but h c by lambda. two photons are having equal, and what is momentum? Momentum of a photon we have seen in Compton effect, h nu by c. Okay, right? So when h nu is same, momentum also will be same, but again the magnitude only will be equal. We are not sure about the direction, so second option also, right, is not 100% correct. Okay, maybe equal, may not be equal. It is like that. Okay, equal frequencies have equal momentum. Okay, momentum is energy, frequency same means momentum also will be same, obviously. Again, the problem is momentum is a vector quantity, direction also should be equal. Now look at the fourth option. Equal momenta have equal wavelengths. When momentum are equal means both photons are moving in the same direction, right? To equal momenta. Okay, equal momentum means their directions are also same, wavelengths are also same. Okay, then wavelengths will be equal. Okay, so the same thing what we have seen in the earlier problem. Okay, two particles in there moving in opposite directions, their momenta will be should be equal and opposite, because total initial momentum is 0. So we can say that two photons having, right, equal momenta, the momentum equal, wavelengths will be equal. Wavelengths are scalar quantities. Okay, equal momentum means the direction is also same. Okay, so this is another question. Next, let us go to a question. An alpha particle and a proton are both accelerated through a potential difference of 100 volts. The ratio of lambda p to lambda alpha to the nearest integer is, he is asking. Okay, it is integer type or numerical answer type question. Okay, or integer type also in some exam patterns. Okay, so they are accelerated through same potential difference. What is the de Broglie wavelength of a particle accelerated through? Right, some potential difference lambda equal to h by under root 2m ek, that is general formula. Okay, for a charged particle accelerated through, right, v volts, kinetic energy ek equal to q into v. Therefore de Broglie wavelength lambda equal to h by under root 2m qv, we can say 2m qv. Okay, for proton I'll write this as lambda p equal to, right, h by under root 2 into mass of the proton into charge of the proton into potential difference. Okay, accelerating potential. Whereas for alpha particle I'll write lambda alpha equal to h by under root 2 m alpha, right, q alpha into, they are accelerated to the same potential difference, means v is same in both cases. Okay, so this is lambda p by lambda alpha. Okay, if I take lambda p by lambda alpha, h bar 2 and v, they get cancelled. Okay, what is lambda p by lambda alpha? This goes up m alpha q alpha. Okay, by, right, mp qp under root. What is m alpha? Mass of the alpha particle is 4 times the mass of the proton. Charge of the alpha particle is double that of the proton's charge. Okay, that is, right, this ratio becomes m alpha is 4 mp, q alpha is 2 qp, okay, by mp into qp, whole thing under root. mp qp get cancelled, so it is nothing but root 8. Root 8 is 2 root 2. 2 root 2. Root 2 is 1.414. 2 into 1.414, around 2.82 approximately. 2.82. Okay, 2.82. Integer type answer, isn't it? So what is the nearest integer to it? It is 3. So the answer will be 3. Answer will be 3. Okay, the same question may come in many ways. Okay, this is one popular, very popular question. Okay, right, a alpha particle and a proton, or a proton and a deuteron are accelerated through same potential difference, or a proton, alpha particle, deuteron and alpha particle, all three particles are accelerated through same potential difference. What is the ratio of their de Broglie values? Lambda p is to lambda d is to lambda alpha. That type of questions also can appear. Okay, or they may say, instead of potential difference, they may say, right, different proton and an alpha particle are having same kinetic energy. Proton and alpha particle are having same kinetic energy. What is the ratio of the de Broglie values? Then we don't have to go into QE, because kinetic energy QE is same, EK is same. So lambda is proportional to 1 by root m. We write lambda is proportional to 1 by root m. Okay, right? Sometimes they have same velocities. Okay, when lambda same velocities means lambda equal to h by mv directly. When particles are having same velocity, then de Broglie wavelength is proportional to 1 by m. Like this, the question may come in 101 variations. Okay, so you can practice this for not only this, proton and alpha particle. You can try for 3 particles also. Proton, deuteron and alpha particle are accelerated through same potential difference. What is lambda p is to lambda d is to lambda alpha? That also you can take it as an exercise. Okay, right? And the proton, deuteron and alpha particle have same kinetic energy. What is the ratio of their de Broglie wavelengths? That is one question. The reverse can also be expected actually here. A proton, a deuteron and an alpha particle all are having same de Broglie wavelength. Find the ratio of their kinetic energies. Reverse question also may come. Okay, means one question, if you see, you can modify it in 5-6 different ways and you practice. That's what we practice. Okay, right? That's how we should practice prepare for the exam. Okay, so the ratio is around 2.8 to a nearest integer will be 3. Okay, the next problem. Yeah. The de Broglie wavelength of an electron moving with a velocity of 1.5 into 10 to the power 8 meters per second is equal to that of a photon. Okay, that is de Broglie wavelength of an electron, lambda e, is equal to the de Broglie wavelength of a photon. Okay, what is the information he has given, right? Velocity of the electron is 1.5 into 10 to the power 8 meters per second. Okay, is equal to that of a photon. The ratio of the kinetic energy of the photon to that of the electron. Okay, kinetic energy of the photon to that of electron means it is like this. Okay, right? Kinetic energy of the photon by kinetic energy of the electron. How much he is asking. Okay, photon, remember, photon is a particle of what you call quantum of an electromagnetic wave. Photons will not have rest mass. Rest mass of a photon is 0. Okay, so whatever energy E, the equal to HU, that is entirely kinetic in nature. Okay, so for in the very beginning of what you call the wave particle duality in photoelectric effect scene, the energy of the photon E is equal to, right, hc by lambda, right? hc by lambda, or lambda equal to, right, hc by E, right? When I want actually numericals, if I put lambda in angstroms, right, if I take this hc as 12,400, we'll get the energy directly in electron volts. That also we have seen there. If lambda is given in nanometers, nowadays most of the exam they are not using angstroms, they are using metric system, that is nanometers only questions are coming. If lambda is given in nanometers, it will be 1240 by lambda. If lambda is in nanometers, right, the energy will be in electron volts directly. No other conversion factor is required. Simply 1240 by lambda, lambda should be nanometers. We will get directly the energy in electron volts. If lambda is given in angstroms, it is 12,400 because 1 nanometer equal to 10 angstroms. Multiply with 10 here and here, 12,400 by angstroms we get. So what is de Broglie wavelength of a photon? Wavelength of photon or de Broglie wavelength of photon is lambda equal to hc by E. Okay, this is the de Broglie wavelength of the photon. Okay, this is equal to the de Broglie wavelength of the electron moving with a velocity 1.5 into 10 to the power 8. Now carefully observe this velocity. 1.5 into 10 to the power 8 means, right, velocity of the electron is equal to, what is velocity of light? 3 into 10 to the power 8 meters per second. Okay, 3 into 10 to the power 8 meters per second. This is 1.5 into 10 to the power 8 meters per second means, if this I'll take it as c, right, the velocity of this electron is c by 2. Velocity of the electron is c by 2. When the velocity of a particle is comparable to the velocity of light, okay, we have to go for relativistic mechanics only. Okay, I cannot use simply take mass of the electron as 9.1 into 10 to the power minus 31 kg. Okay, we have to take rest mass, variation of rest mass with velocity m equal to m naught by root of 1 minus v square by c square. I should substitute. Okay, so it is a relativistic electron. Okay, so I have to use relativistic formula only, right, is equal to that of a photon, the ratio of the kinetic energy of the photon to the electron. Okay, now this is the, okay, this is the de Broglie wavelength of, or normal wavelength of the photon only. Okay, remember this. What is de Broglie wavelength of the electron? De Broglie wavelength of a relativistic particle. de Broglie wavelength of a relativistic particle, the formula is like this. Okay, for a relativistic particle, de Broglie wavelength is lambda equal to hc by, right, under root k kinetic energy into k plus 2m naught c square, where m naught c square is rest mass energy of the electron. Okay, k is kinetic energy of the electron. So de Broglie wavelength of a relativistic particle is not simply lambda equal to h by mv, right? We'll see, we'll derive this later on. Okay, after completing this problem, I'll derive this formula also. hc by under root k into k plus 2m naught c square. What is k? K is kinetic energy of the relativistic kinetic energy of the electron. So what is relativistic kinetic energy of the electron? K equal to general formula for any kinetic energy, half mv square only, no doubt. Only thing is, for a relativistic particle, right, m equal to relativistic variation of mass with velocity, m naught by root of 1 minus v square by c square I should take. So this is nothing but half into m naught by root of 1 minus v square by c square into, right, velocity. Velocity is how much? V equal to c by 2. 1.5 × 10 to the power 8 meters per second is nothing but c by 2. Okay, so c by 2 whole square, that is c square by 4. C square by 4. Now what is V here? V is also c by 2 only, that is c square by 4. C square gets cancelled. 1 minus 1 by 4. 1 minus 1 by 4 is under root. 1 minus 1 by 4 is root 3 by 4. Okay, root 3 by 4 under root is root 3 by 2. So this becomes, the 2 goes up, and I'll write like this, 1 by 2, right? 2 goes up, 2m naught by, right, root 3 into c square by 4, into c square by 4. Okay, this is the relativistic kinetic energy expression of the electron. Okay, so this 2 and 2 gets cancelled. It is nothing but m naught c square by 4 root 3. This is the kinetic energy expression. In the expression for a de Broglie wavelength, we have 2m naught c square here. So from this expression only, and he is asking us the ratio of the kinetic energy of the photon to that of the electron. So I have to take k out. So I have to convert this m naught c square also in terms of k, right? So m naught c square is equal to, right, 4 root 3 k. 2m naught c square will be 8 root 3 k. 8 root 3 k. Now substitute this 2m naught c square equal to 8 root 3 k in this formula. We'll get de Broglie wavelength of the electron. Okay. So de Broglie wavelength of the electron is equal to hc by under root k into k plus 2m naught c square is 8 root 3 k. Now take k common. Okay, right, take k common. K into k square plus 8 root 3 k square common, under root comes out, root, and when it comes out of the root, it will be k only. So lambda e equal to hc by k into root of 1 plus 8 root 3. Okay, k into root of 1 plus a root 3. Okay, so this is the expression for the de Broglie wavelength of the electron. What is de Broglie wavelength of the photon? How much have we got? Hc by E we got. Okay, this is equal to the de Broglie wavelength of the photon, which is nothing but hc by E. hc gets cancelled. That is, the kinetic energy of the photon means total energy of the photon only, is equal to k into root of 1 plus 8 root 3. What is he asking? The ratio of the kinetic energy of the photon to that of the electron, that is E by K ratio is asking. So what is E by K? E by K is equal to under root 1 plus 8 root 3. Okay, so root 3 is 1.732. 8 into 1 plus root 3, right, 4. This approximately comes to around 3.8. This is also a numerical answer type question. Okay, in the system you are allowed to use that calculator, numerical calculator. So you'll get roughly around 4, around 3.8 or 3.9 you will be getting. 1 root of 1 plus 8 root 3. So what is the nearest integer? Okay, it's around 4. Okay, right, this is another good problem. Okay, now we'll see the next problem. Yeah. This is a longer problem, but there are 3 questions here. Okay, it's like a 3 marks problem. Okay, if you have understood comprehension type questions, these are known as, if you have understood the concept, 3 questions means 3 marks are in your pocket only. Okay, right? If it's not understood, 3 marks are gone. Right, like AC/DC problems, these are. Okay, right? What is that? Consider that the matter wave of an electron forms a standing wave between atoms in a one-dimensional array. Okay, one-dimensional array with nodes at each atomic site. Means one-dimensional array of atoms means the atoms are arranged in one-dimensional lattice. Okay, separation between 2 atoms is constant. Okay, right? So with node forming at each atomic site. Okay, standing wave means it will be like this. Standing waves means it will be like this. These points are nodes, these points are antinodes. The nodes always are occurring at the atomic site, he is saying. Okay, it is found that one such standing wave is formed when the distance between the 2 atoms is 2 angstroms. Means if the distance between 2 atoms is 2 angstroms, one standing wave has been formed. Okay, a similar standing wave is again formed if the distance is increased to 2.5. Means if the distance between the 2 atoms is increased to, right, 2.5 distance, another standing wave is observed. When the distance is 2 angstroms, one standing wave pattern is observed. When the distance is 2.5 angstroms, another standing wave pattern is observed. Okay, that's the question, but not for the intermediate value of D. Means till the distance is 2.5, no standing wave is observed. So first standing wave pattern, right, is observed at 2 angstroms. Next standing wave pattern is observed at 2.5 angstroms. Okay, right? Now what are the problems, what are the questions given? The wavelength of the de Broglie wave of that electron is. Okay, now if we have an idea of standing wave pattern in oscillations and waves, okay, standing wave between 2 points, 2 fixed nodes, okay, the minimum wavelength is lambda. Okay, that is one node will be formed in standing wave. For the next mode, it will be like this. Okay, right? For the next mode, this is called, one loop means first mode of vibration, 2 loops means second mode of vibration, 3 loops means third mode of vibration, like this. Okay, third mode of vibration. If the standing wave is like this, the wavelength is equal to, right, the distance between the 2 nodes. Okay, distance between the 2 nodes is the wavelength here when it is in second mode. Okay, when it is in first mode, the distance between the 2 modes will be only one loop is formed, so it should be lambda by 2. So here the distance between the 2 nodes D is equal to, okay, in the first mode it is 2 lambda by 2. In the second mode it is 1 lambda, so I can take it as 2 lambda by 2. In the third mode it is 3 lambda by 2, like that. Okay, in general the distance between the 2 nodes should be n lambda by 2 in standing wave pattern. Okay, he said that when the distance between 2 angstroms, when the distance between 2 atoms is 2 angstroms, a standing wave is formed, but which mode of standing wave he has not mentioned. So 2 angstroms is equal to n lambda by 2 in general. What is that n? We don't know. Okay, whether it's first mode or second mode or third mode, I don't know. Okay, he has not given that. Only thing is distance between 2 atoms is n lambda by 2. Okay, when it is 2 angstroms. Okay, right, next one. The next similar standing wave is again formed if the distance is increased to 2.5 angstroms. Means what? If this is nth mode, here also another standing wave pattern is observed between these 2. Okay, whatever it is, if this is the nth mode, this should be n plus 1th mode. Okay, that is n plus 1 into lambda by 2 is equal to 2.5. Okay, so now see. Okay, n lambda by 2 is 2 angstroms, n lambda by 2 plus lambda by 2, I am splitting this, is equal to 2.5 angstroms. Okay, so n lambda by 2 is 2. 2 plus lambda by 2 is equal to 2.5, or lambda by 2 equal to, okay, how much? 2.5 minus 2, that is 0.5. Lambda equal to 1 angstrom. Okay, so the de Broglie wavelength of, right, that electron making a standing wave pattern between 2 atoms will be, right, 1 angstrom. Will be 1 angstrom. the minimum value of d for which the formation of standing wave. What is the minimum value of d? If the wavelength is 1 angstrom, right? It is second mode, it will be 2 loops. First mode also is possible. Okay, right? Means what? For 0.5 angstroms also, half wavelength, one node, one standing wave pattern can be formed. Means for 1 angstrom wavelength, what is the minimum distance for a standing wave to be formed? Half angstrom is sufficient, lambda by 2 will be there. Okay, so the answer here is the minimum wavelength, minimum value of d for the formation of standing wave is how much? 0.5 angstrom. Electron volts is, okay. Now look here, the energy of the electron means de Broglie wavelength is 1 angstrom. We have seen in what you call the very beginning of de Broglie concept of matter waves. Okay, how do we estimate de Broglie wavelength? There is one shortcut formula I told, a simplified formula. Okay, what is that? De Broglie wavelength of an electron is equal to under root 150 by V volts. If V is in volts, lambda will be in angstroms. Okay, what does that mean? Right, if lambda equal to 1 angstrom means, right, the energy should be around 150 electron volts. Okay, so the nearest option, I have taken this as an approximation. So for 1 angstrom wavelength, the energy will be around 150. Now look here, the energy of the electron volts will be 151 is the nearest option, because other one is 15.1, 1.51, 0.51. Okay, so it is 151 angstroms. This I am directly writing from this formula, lambda equal to 150 by V volts. 1 angstrom is equal to, this is what we have got, simplifying all that formula. Okay, what is that? Lambda equal to h by under root 2m qv. Okay, qv is nothing but energy of the electron in electron volts. I have substituted mass of the electron, charge of the electron, h value, 2 value substituted and simplified, leaving out only V, I'll get this. So when what you call that is energy will be equal to 150. So the energy of the electron in electron volts is 151 electron volts. Okay, so all the 3 questions can be right. Only thing, problem is lengthy. Okay, in JAM exam or in IIT JEE, it takes nearly 1 minute for you. Sometimes some problems are given unnecessary information. It's not unnecessary information, they'll give you all details. Okay, take the mass of the electron as this much, take the velocity of light as this much, etc. Reading only nearly half minute to 1 minute will get wasted. Okay, but if there are 2 or 3 questions associated with it, you'll get 3 marks, right? So this is one more good problem. The next one is, there is a mistake in this problem. This we have seen, this we have seen. Okay, yeah, I told you the expression for the de Broglie wavelength of a relativistic particle. Now we can derive that. Okay, right, a very simple derivation. Yeah, general formula for de Broglie wavelength of any particle is, okay, lambda equal to h by p. Okay, for a relativistic particle, the total energy is given as, okay, E square equal to, or E equal to under root p square c square plus m naught c square. Okay, this is the expression for total energy according to relativity. Okay, for relativistic particle, right, E is the total energy, P is relativistic momentum, E equal to under root p square c square plus m naught c square. Okay, m naught c square, m naught square c to the power 4. Yeah, m naught square, it is c to the power 4. Okay, yeah, what is m naught c square? It is known as rest mass energy of the particle. Now let us see, before going into deriving the de Broglie wavelength, let us first derive this problem. Okay, this expression. One thing I'll take directly from special theory of relativity. According to special theory of relativity, okay, particles mass is not absolute. Okay, relativity has proved that all the 3 terms in our dimensional formula, mass, length, time, all are relative only. That is the speciality of special theory of relativity. At the time of Newton, right, classical mechanics, or Newton thought that mass is absolute, length is absolute, time is absolute. Okay, length of the pen is 10 centimeters, means it will be 10 centimeters for everybody. Okay, right, mass of this pen is 10 grams, means mass of the pen will be 10 grams only for everybody, he thought. Okay, it is not weight. Weight varies with g. Okay, mass remains constant everywhere. Okay, similarly, time is also absolute, they thought. That is, suppose I took this lecture for 1 hour. Okay, anybody observing this lecture from anywhere, any observer will find that my lecture's duration is 1 hour only. Okay, but relativity said mass is not constant, length is not constant, even time also is not constant. Okay, that is special. It has smashed all the concepts of, right, absoluteness of mass, length and time. According to relativity, see, here in India, our time is, suppose I'm starting the class at around 3 o'clock in the afternoon, I'll end the class at about 4 o'clock. Okay, means duration of my class is 1 hour. Suppose say the moment I start the class here, you send a WhatsApp message to your friend in Russia and to your friend in America. Okay, in America time may be night 1 o'clock. In Russia time may be early morning 5 o'clock. Okay, so the moment I start my class, you'll send one WhatsApp message. Okay, so they'll note down their times in their countries, in their time zones. The moment I end my class here, okay, I started at 3 p.m, I have ended at 4 p.m, so I'll immediately send one more message to both of your friends. Okay, so if it is night 1 o'clock for the fellow in America, right, the ending time of my class will be 2 o'clock. Okay, right, similarly for a person in Russia, if it is early morning 5 o'clock, okay, right, the ending time of my class will be 6 o'clock in the morning, early morning. Means that fellow also says that my class duration is 1 hour. All the 3 people will say that duration of class is 1 hour only. That's not relativity actually. There is some observer in the universe, okay, who is moving with some velocity. He will say that you will send, he is going in some rocket with some velocity, say c/3 velocity, is moving away or coming down or whatever it is. Okay, his movement is, he is moving with velocity of c/3 in a rocket. He also is having one phone. You will send one WhatsApp message to him. Okay, he will note down that the class has started at morning 9 o'clock when you send the first signal. When you send the second signal to him, his watch will show only 40 minutes. Means he will say the class has started at 9 o'clock in my watch, okay, and ended at 9:40. So duration of class is only 40 minutes, whereas your watch is showing duration of class as 1 hour. Okay, so what is 1 hour time gap for you, time duration for you, is not 1 hour time duration for him. It will be 40 minutes or 30 minutes or 60 minutes, 50 minutes, depending on his velocity. That's relativity. That was unimaginable actually. When relativity came out with these concepts, these things were unimaginable. Okay, that's why relativity has become so popular. Okay, right, similarly mass, okay, that mass also is not constant, it depends on the velocity set. That's known as relativistic variation of mass with velocity. Okay, similarly length of this pen, okay, you measure the length of the pen, you put one scale here, the starting point is at 10 centimeters, the ending point is at suppose at 20 centimeters, 20 minus 10, length of the pen will be 10 centimeters for you. You will think that anybody, right, measuring the length of the pen will get only 10 centimeters, but there will be some observer in the universe moving with some velocity v. He says he will put his scale here, okay, starting at 10 centimeters. For him, length will, the ending point will be only at 8 centimeters, means 18 centimeters, means he will say length of the pen is only 8 centimeters. What is 1 10 centimeters long pen to you is only 6 centimeters or 7 centimeters long pen for him. Similarly, you are 6 feet tall. For some observer, you look like as if you are 4 feet only. Okay, that's called length contraction. Length also depends on the velocity with which the observer is moving, or the velocity with which the object is moving, whatever it is. Okay, velocity is also relative in relativity. So, according to relativity, okay, right, mass is not constant, but mass varies with the velocity as m0 by root of 1 minus v square by c square. m0 is called rest mass of the particle. m0 is called rest mass of the particle. This is the mass when it is moving with some velocity v. According to Einstein's, right, E equal to mc squared. Right, every mass is equivalent, can be converted into energy. Okay, right, mass multiplied by c squared, which means even a very small amount of mass, because it's getting multiplied by c squared, 3 into 10 to the power 8 meters per second whole square, it will contain large amount of energy. Okay, right, that's how atom bomb was designed, based on this concept only. Okay, so E equal to mc square. if the particle is at rest without any motion, right, the mass measured when it is at rest by an observer who is also at rest with respect to the mass is called rest mass m naught. Okay, let it not move, it will not have kinetic energy. It is also on the ground, potential energy is also 0, but just because it is having some mass, Einstein says it will have some energy. Okay, that mass also is another form of energy. Energy, mass energy equivalence we call. What is the energy of that particle which is possessing a rest mass m? It is m naught c square. I'll call that as rest mass energy E naught. Okay, if this particle now starts moving with a velocity v, right, its mass is no longer m naught, the mass keeps on changing with velocity like this. How much will be its mass, right, depends on the velocity with which it is moving. Okay, right, in the special theory of relativity we will derive m equal to m naught by root of 1 minus v square by c square. Now if its mass is m, right, its energy will now be equal to mc square. It will be mc square. So E equal to mc square if the particle is moving with some velocity v. E naught equal to m naught c square when the particle is at rest. This is called rest mass energy. Only this is constant. Okay, this depends, keeps on varying with velocity. Okay, so right, now because m equal to, right, m naught by root of 1 minus v square by c square, what is energy of the particle? Energy of the particle E equal to mc square. M equal to m naught by root of 1 minus v square by c square. So energy equal to like this. Similarly, what is momentum? Momentum of the p equal to m into e. Okay, right, what is m equal to again? M naught into v by root of 1 minus v square by c square. Okay, this is according to relativity, right, the energy and momentum of a particle. Every particle of mass m should have some momentum when it is moving, and it will have some energy also. Okay, so its energy is how much? M naught c square root of 1 minus v square by c square. Linear momentum is m naught v by root of 1 minus v square by c square. Now for zero rest mass particles, okay, the most interesting aspect here is for a zero rest mass particle. Okay, for a zero rest mass particle, the situation changes like this. Rest mass is 0. There are some particles in the universe with zero rest mass. Best example is photon only. Rest mass of photon is 0. Okay, what happens if rest mass of the particle is 0? M not equal to 0 means this whole thing becomes 0. Okay, similarly momentum also equal to 0, that is energy of the particle is 0, momentum of the particle is also 0. Energy of the particle is 0, momentum is 0. When a particle is not having rest mass is 0 means it is not having mass. Okay, right, it is not having momentum, it is not having energy. What does that mean? Particle does not exist. Means zero rest mass particle, right, should not exist because looking at these two equations. Okay, but we are seeing particles with zero rest mass. Best example is light photon. Okay, it has no rest mass, but it is still existing. How is it existing? It should not have any energy, it should not have any momentum. Okay, now how is it possible relativistically? Means say its rest mass is 0. Its rest mass is 0, that is m not equal to 0 but v equal to c. Then what will happen? Okay, if m not equal to 0 and v equal to c, right, energy of the particle becomes m not equal to 0, numerator is 0, by, in the denominator also, v equal to 0. V equal to 0 means what will happen? Right, so v equal to c, sorry. Okay, v equal to c means c square by c square. C square by c square is 1. 1 minus 1 is 0. Root 0 is 0. E equal to 0 by 0. Okay, similarly, what is linear momentum of the particle? M not equal to 0, numerator is 0. If v equal to c, means if zero rest mass particle moves with velocity of light, okay, v equal to c, it will be c square by c square. 1 minus 1 is 0, means, right, p equal to 0 by 0. What is 0 by 0? What is the meaning of 0 by 0? Undefined. Okay, 0 by 0, infinity by infinity we call them as undefined. Okay, or indeterminate we call. Okay, what is the meaning of undefined? Well defined only we don't understand sometimes. How about undefined things? Undefined means if some parameter you got undefined, it does not mean that you have to close your books and go to sleep. Okay, undefined means, why do we say it is undefined? It can have any value. It can have any value. Any energy it can have, any momentum it can have. I cannot define that it should have this much momentum only or this much energy only. Okay, it can have any energy, any momentum. That's why its energy and momentum are coming as 0 by 0. So wherever you get 0 by 0, once in solution physics, Fermi energy also will get the expression Fermi distribution function f of e becomes half. Okay, f of e, right, you'll get 0 by 0. What does that mean? You cannot define the function. It can have that probability of an electron can have any value from 0 to 1 in Fermi-Dirac statistics. Okay, 0 by 0 means what? The particle can have any energy, particle can have any momentum. I have no objection, or relativity has no objection. Only thing is what? The condition is, if at all a zero rest mass particle has to exist, means it should move with c. It should move with c. Okay, that is the condition. If m not equal to 0, right, velocity of the particle must be equal to c. Okay, then only such a particle can exist. It can exist with any energy it likes. It can exist with any momentum. That's what is happening. Light photons, energy equal to hν. Depending on the frequency, photon can have any amount of energy, right? Momentum is hν by c. Depending on its frequency, it can have any value of momentum. Okay, so this is the condition for the existence of a zero rest mass particle. If m not equal to c, the particle must move with velocity of light only. That is nothing but the second postulate in special theory of relativity. The velocity of light in free space is constant for all inertial observers. Okay, right? Velocity of light should be c only. Okay, because photons have to move with c. If they do not move with c, they cannot exist. They disappear. Means nobody can say that one photon is going, he cannot say. Everybody should measure its velocity as c only. Nobody can measure its velocity other than c. Anything other than c, photon disappears, which becomes meaningless, because for one fellow photon is existing, the other fellow photon is not existing. Means for one fellow light is there, another fellow light is not there. That is meaningless, isn't it? So what should happen? Every person should measure the velocity of light as c only. That is, velocity of light in free space is constant for inertial observers. All these things add up to that point. Okay, that's what relativity in Einstein said in the second postulate. Okay, right? So what does that mean? Right, particle can have any energy, any moment, provided it moves with c. Now we'll again manipulate, or what you call, do some mathematics with these two equations. Okay, right? So E equal to m naught c square by root of 1 minus v square by c square. I'll take LCM, c square minus v square by c square, right? C square comes out of the root, okay, comes and becomes c here. So E equal to, what is momentum? Momentum P equal to m naught v by root of 1 minus v square by c square. In general, for any particle, zero rest mass particles have to exist, means they should move with velocity of light. See, that is concluded. Okay, now in general, E equal to m naught c square by root of 1 minus v square by c square, P equal to m naught v by root of 1 minus v square by c square. Now you square this. Okay, E square will be what? M naught square c to the power 4 by the square root goes off, right? 1 minus v square by c square means, if you take LCM, c square minus v square by c square. C square minus v square will remain the denominator. That's by c square will go up and become c to the power 6 here. So E square equal to m naught square c to the power 6 by c square minus v square. Similarly, you square this momentum also. Okay, so what do you get when you square this momentum? Right, this whole thing square, if you do, it is m naught square v square by, square root goes off, again c square minus v square by c square goes up. Okay, it is, right, c square minus v square. Now multiply both sides with c square. Okay, this side and c square, already one c square is there, it will become c to the power 4. Now E square minus c square, p square c square you do. E square minus p square c square means this minus this, m naught square c to the power 6 by c square minus v square by this whole thing by c square. Both are having common denominator, so I'll write this as, right, c square minus v square, m naught square c to the power 6 by m naught square c square v to the power 4. M naught square c to the power 6 minus m naught square, right, v square c to the power 4. Now you can take m naught square c to the power 4 common. Okay, if you take m naught square c to the power 4 common here, m naught square c to the power Out of 6 I am taking 4 common, so one c square term will remain here in this one. M naught square c to the power 4 I have taken common, so v square remains. So this is c square minus v square by c square minus v square. Okay, so c square minus v square, c square minus v square gets cancelled. Okay, right, this is m naught square c to the power 4. That is nothing but e square minus p square c square equal to, okay, e square minus p square c square equal to m naught square c to the power 4. Okay, that is e equal to under root p square c square plus m naught square c to the power 4. What is m naught square c to the power 4? M naught c square is rest mass energy. M naught c square is rest mass energy. M naught square c to the power of nothing but square of this one. That is, it can be written as p square c square plus E naught square also you can write. Okay, right? This is the expression for the total energy of a relativistic particle. Total energy of a relativistic particle is, right, p square c square plus m naught square c to the power 4. From total energy, if you remove rest mass energy, you will get kinetic energy. That's known as relativistic kinetic energy. What is relativistic kinetic energy? Right, from this total energy, remove its rest mass energy. Okay, that is relativistic kinetic energy, ERK I will write, or I will take it as EKR, means kinetic energy. Relativistic kinetic energy is total energy minus rest mass energy m naught c square, means this whole thing minus m naught c square, that is under root p square c square plus m naught square c to the power 4. This is total energy minus m naught c square will give you relativistic kinetic energy. Okay, so remember this expression. This E equal to under root p square c square plus m naught square c to the power 4 is the most popular equation, right, according to special theory of relativity. That is the expression for total energy of a particle. Now the most popular question out of this equation is, right, the question, if the rest mass of particle is 0, see, we have seen particle should move with velocity of light to exist. Okay, if the rest mass of the particle is 0 and suppose say it is not, okay, we substitute that here, what happens we'll see. If m naught equal to 0, then what happens? E equal to root of p square c square. That is nothing but E equal to pc. E equal to pc. E equal to pc. E is for which particle? Particle without rest mass, or rest mass equal to 0. This is a popular question which has appeared from IIT JEE to IIT JAM to even CSR JRF also. This question has appeared. Okay, in almost all the exams I have found this question. E equal to pc is applicable only for, is applicable for all particles, particles with rest mass only, particles without rest mass, particles some moving with c, something like that they ask. Okay, or whatever, what is this, right, expression E equal to pc. E equal to pc is applicable only for particles with 0 rest mass, means it is applicable for photon, not for any electron, proton or any neutron like that. Okay, so E equal to pc is applicable only for, right, 0 rest mass particles. For particles having rest mass, what is the total energy? Okay, this is nothing but for de Broglie concept only. P equal to h by lambda. Okay, C equal to h by lambda, hc by lambda. Okay, this is nothing but hc by lambda, nothing but h nu only. All again lead to the same thing. Means relativity is not differing from any quantum theory. Okay, right? So P equal to h by lambda according to de Broglie concept. H by lambda, that's not hc by lambda. Hc by lambda, c by lambda is nothing but nu, no? So E equal to h nu is nothing but energy of the photon. That's what Max Planck's quantum theory is. Okay. So remember these expressions. Okay, again at the end of nuclear physics we'll come across the same expression. From here we'll go into what is known as pair production. Okay, how energy can be converted into mass, right? If now you understand an electron should be created, means what is the rest mass energy of the electron? M naught c square. If I put rest mass of the electron as 9.1 into 10 to the power minus 31 kg, m naught into c square if I do and convert that into electron volts, rest mass energy of the electron is obtained as, or is equal to rest mass energy of the electron m naught c square is equal to 0.511 MeV. Okay, that is known as rest mass energy of the electron. What is m naught? Rest mass of the electron is 9.1 into 10 to the power minus 31 kg. What is rest mass of the proton? right? This can be written as what you call 511 keV also, 0.511 MeV, or in the exams mostly they'll give, take the rest mass of the electron as 0.5 MeV. That's how they, okay, approximate value they give, okay, to simplify the mathematical aspect. Okay, what is rest mass of a proton? Rest mass of a proton, if it is MP, right, its rest mass energy will be equal to, right, for proton rest mass energy is MP c square, right? It is MP is about 18, mass of the rest mass of proton is about 1836 times that of the electron, isn't it? So you have to multiply this with 1836, it will be around 938.2 MeV. Okay, this is rest mass energy of the proton. Okay, what is rest mass energy of the neutron? Neutron equal to rest mass of the neutron, Mn into c square. Neutron's mass is slightly more than that of proton. Okay, proton's mass is 1.67 into 10 to the power minus 27. Neutron's mass is 1.675 into 10 to the power minus 27, which is slightly greater than, right, rest mass of proton. So rest mass energy is around 939.5 MeV. 939.5 MeV. Okay, so energy in MeV. Now energy in general is m naught c square equal to 0.51 MeV. So what is rest mass of the proton electron? Means in particle physics, okay, when we go into particle physics, right, the mass of the proton, rest mass of the electron is equal to how much? 0.511 MeV by c square. I'll write MeV by c square becomes unit of mass. Okay, unit of mass in particle physics. Okay, so what is rest mass of an electron? It is 0.511 MeV by c square. An electron, right, with mass 0.51 MeV by c square means I'll understand that the electron is at rest. If somebody says an electron has a mass of equal to 1 MeV by c square, what does that mean? If it is at rest, it should have only 0.51 MeV. How is it getting 1 MeV? That is around 0.5 MeV more. That is nothing but kinetic energy. Okay, means what? That particle is not at, that electron is not at rest. It is in motion with its kinetic energy 1 minus 0.511, or approximately its kinetic energy is 0.5 MeV. Similarly, a proton is having a mass of 938 MeV or 938.2 MeV. I'll understand that fellow is saying that the proton is at rest. Proton of mass 1 BeV, 1 billion electron volts. Okay, it is around roughly 1000 MeV. Okay, 1000 MeV means 1 BeV only, but its rest mass is 938 only. This 1 BeV means what? 1 BeV means 10 to the power 9, that is 10 to the power 3 MeV, 1000 MeV. That is remaining 62 MeV. What is that? 62 MeV is the kinetic energy of the proton. Okay, so proton's mass is 1 BeV by c square, means I'll understand that proton is not at rest, it is having some motion, it is in motion, its kinetic energy is 1000 minus 938, that is 62 MeV by c square is its extra mass because of its kinetic energy, like this. Okay, right, this is how we got that expression. Also I'll have substituted what you call from E equal to under root p square c square by, sorry, p square c square plus m naught square c to the power 4. Right, what is de Broglie wavelength of a relativistic particle? Right, h by p. I'll take out p from this expression. I'll take out p from this expression. Okay, right, that p equal to under root what? P equal to p square c square, nothing but e square equal to, right, p square c square plus m naught square c to the power 4. So what is p square c square equal to? E square minus this m naught square c to the power 4, I'll take it as e naught square. So p square, p equal to, directly I'll write e square minus e naught square, right, by c square under root, means it will be like this. Okay, this is relativistic momentum, so I'll substitute that in this formula. Lambda equal to h by p means p equal to this much, the c goes up and it becomes hc by, right, under root e square minus e naught square. Okay, you simplify this formula further, what you get is, in terms of relativistic kinetic energy, lambda equal to hc by under root k into k plus m naught c, 2m naught c square. Okay, the in between 2 or 3 steps you can fill up. Okay, take it as a small exercise. E equal to E is total energy, you know, E naught is, you want kinetic energy, right? What is kinetic energy? Right, total energy nothing but rest mass energy plus kinetic energy. So E square equal to E naught plus k whole square. put that substitute here, you'll get this one. This is the expression for the de Broglie wavelength of a relativistic particle. That's what we have used in the earlier 1 or 2 problems. Okay, so this is about what you call the de Broglie concept. Okay, we'll go into some uncertainty principle concepts in the next video. We'll see what exactly uncertainty means. Okay, why I cannot measure the position and movement of particles simultaneously accurately, or how Heisenberg has arrived at that value delta x into delta px greater than or equal to h bar by 2 is approximately of the order of h, we say. Okay, because uncertainty principle has come after Schrodinger wave equation, remember. Okay, after Schrodinger wave equation, uncertainty principle has come, right? Those aspects we are going to mathematical formulation we have seen in the previous video. So I'll go slightly theoretical insight, right? We'll have some theoretical insight how this uncertainty principle is, in what way it makes some sense. Okay, why it makes some sense, we'll see in our next video. Thank you.